Hello, and welcome to the Cost-Benefit Analysis Group 1 Lab 4 presentation. Problem 1 deals with changes in consumer surplus as a result of changes in price. Specifically, we aim to analyze the loss in consumer surplus as a result of a price increase from $1.25 to $1.75. In Part 1, we estimate using the linear curve of the right side graph, which has the function q equals 18 minus 2.8f, where q is quantity and f is price. Consumer surplus is defined as the trapezoidal area of the graph, which is bound by points B and C, and the markers on the vertical axis for $1.25 and $1.75. Consumer surplus loss can be divided into the triangular region with area $0.35 million and the rectangular region with area $6.55 million on the left. Summing them together results in a consumer surplus loss of $6.9 million. Part 2 follows a similar concept, but with the curved constant elasticity graph, which has the function q equals 15.2 times f raised to the negative 0.2 power. The area equation in large font on the left attains the full area under the curve. The lower rectangle is bound by point B, the point in the red circle, and 13.59 and 14.53 on the horizontal axis, which are the ending and starting quantities respectively. The left rectangle is bound by point D, the point in the red circle, and $1.25 and $1.75 on the vertical axis, which are the starting and ending prices respectively. The loss in consumer surplus is the full area under the curve minus the lower rectangle plus the left rectangle, which results in an area of $7.02 million defined by points B and D and the markers on the vertical axis for $1.25 and $1.75. Problem 2 deals with gross benefits with different fees at a public swimming pool in a town called Dryville. The data in the yellow area was given, and the Dryville population of 70,230 and average income of $31,500 were also given. From there, the expected number of visitors was defined as a function of the fee, their income, and the population. The results of our regression in Stata is the orange rectangle. With Dryville's given population and average income, a linear function was derived, which would be its demand curve with slope, intercept, and predicted data points in the green section. In the first part of the question, the fee is 0, which means that the whole triangular region under the demand curve is consumer surplus. Consumer surplus will be equal to gross benefits in this case. The area of the region was calculated to be $1,141,809.19. In Part 2, there is a fee of $1 and a marginal excess tax burden, abbreviated METB, of 0.25, which is the increase in deadweight loss per dollar taxed. In this case, pool visitors pay a usage fee that would have otherwise been tax money. The consumer surplus only accounts for the area under the demand curve above the $1 line, which sums to $966,292.74. The government surplus increases to $168,224.67 as a result of the fee. The marginal cost of public funds, abbreviated MCPF, is 1 plus METB, which equals 1.25. The MCPF acts as a multiplier on the government surplus. So, in total, consumer surplus and weighted government surplus add up to a gross benefit of $1,176,573.57. And that concludes the presentation for Lab 4. Thanks for tuning in.